So far we have seen that when two objects move in the same direction, the relative speed is nothing but difference of speeds. So if they are moving with, say, speeds x kilometers per hour and y kilometers per hour, where x is greater than y, then I can say that in the same direction, relative speed would be difference of speeds, which is x minus y. Similarly, if they are moving in opposite directions, then I can say that relative speed is nothing but sum of speeds, that is x plus y kilometers per hour. Now let's look at one special case. Let's observe this man who is rowing the boat in the forward direction. So he is moving with some speed in the forward direction. Observe that the water is still and there is no stream in the water. Now let's look at another case where this man is still rowing forward, but there is a stream of water which is opposing the motion of the boat. So it is moving in the opposite direction. We can see that here the person is facing difficulty and the speed of his rowing the boat has actually decreased. So the speed decreases. Now let's look at another case when the speed has increased. Why is it so? Because now the stream is also in the direction in which the man is moving. So we see that both the man and the stream are moving in the same direction. So even when the person is not rowing, he is moving forward with the speed of the stream only. So his speed has increased. So now let's carefully note these three cases. Let's say that the speed of the boat is x kilometers per hour. That is the speed of this man who is rowing this boat in still water. So speed of the boat in still water is x kilometers per hour. Say that speed of the stream is y kilometers per hour. Now if the person is moving against the stream, so the person is moving in x kilometers per hour in this direction and the speed of the stream is in the opposite direction. So both of them are moving in opposite directions. What has happened? The speed of the man was decreasing. But so far we have seen that when objects move in opposite direction, the relative speed increases. It is the sum of speeds. But in this case, what happens is, when the stream of water is against the direction in which the man is going, or in which the boat is moving, we say that the man is actually moving upstream. That is against the stream, and hence the relative speed decreases. So relative speed in this case is actually difference of speeds. So far in opposite direction it was sum of speeds, but in this case it is difference of speeds, and we call this upstream because he is moving against the stream. So we call it upstream, and speed upstream would be nothing but x minus y. That is the speed of this boat in still water minus the speed of the stream. This is how you get that. Now let us observe the other case, which is the boat is moving in the same direction as the stream. In this case we actually saw that the person was moving very fast. The speed increased. So far we had seen that when objects move in the same direction, the relative speed decreases. That is, the relative speed is the difference of speeds. But in this special case, when these two are moving in the same direction, that is when the boat and the stream are moving in the same direction, the speed increases. That is, the relative speed in this case is sum of speeds. And since the boat is moving with the stream, we call it downstream. It's moving with the stream, and the speed becomes the sum of speeds, that is the relative speed. So the speed downstream becomes x plus y. That is the speed of this boat in still water plus the speed of the stream. So these two add up. Now let's look at this question. It says that the speed of boat in still water is 8 kilometers per hour and the speed of stream is 2 kilometers per hour. What I want to find is the time that the boat will take to go 12 kilometers upstream and second 35 kilometers downstream. So the first thing is that we're given the speed in still water, we're given the speed of the stream also, so we can find the speed upstream and downstream. So the speed upstream would be when you're moving against the stream. You're moving against the stream, it would take you more time, that is difference of speeds. So here the speed upstream would be difference of the two, which is 8 minus 2. So the speed upstream is 6 kilometers per hour. Similarly, I can find the speed of the boat downstream also. When you're moving with the stream, you're moving downstream. And when you're moving with the stream, the speed increases. So the speed of the boat downstream would be the sum of the speeds. So speeds here are 8 and 2. Sum of both these speeds would be 8 plus 2 kilometers per hour, which is 10 kilometers per hour. So I know the speed upstream, I know the speed downstream. I want to find the time in which this distance is traveled upstream and the time in which this distance is traveled downstream. So let us find the time now. So I want to find the time in which the boat travels 12 kilometers upstream. I've already found that speed upstream is 6 kilometers per hour and I want to find the time for 12 kilometers. So time is nothing but distance by speed. Distance we know is 12 kilometers and speed we know is 6 kilometers per hour. So time taken to go 12 kilometers upstream would be distance by speed, which is nothing but 12 kilometers by 6 kilometers per hour, and this gives me 2 hours. That is, it would take 2 hours to go 12 kilometers upstream. Now let's look at the second case, which is we want to find how much time it will take to go 35 kilometers downstream. We already know that speed downstream is 10 kilometers per hour. That is the sum of both the speeds. So we need to find the time, which is nothing but distance by speed. So time taken to go 35 kilometers downstream would be distance, which is 35 kilometers, divided by speed, which is 10 kilometers per hour. So this gives me 3.5 hours. That is 3.5 hours. So I get 3.5 hours. So it would take 3.5 hours to move 35 kilometers downstream. Now let's see whether you can solve this question. So a man can swim at 6 kilometers per hour in still water. We know his speed in still water. Now he swims 500 meters against a stream in 15 minutes. What will be the speed of the stream? We want to find the speed of the stream. Notice that he swims 500 meters. So the distance that he actually swam is 500 meters. And the time which it took to cover this distance is 15 minutes. But the speed to us is given in kilometers per hour. So we can convert it into kilometers an hour. This would be 500 by 1000 kilometers, which is half a kilometer. And 15 minutes, I want to convert minutes into hours. So again I can divide this by 60. So this is 1 by 4 of an hour. So this is what I know, the distance and time. What I'm interested is in finding the speed upstream. Why is it upstream? Since he's going against the stream, he's going upstream against the stream. When you're going against the stream, then the speed decreases. That is difference of speeds. So we know distance, we know time. This is the distance which he goes in against the stream, that is distance upstream, and time which he takes to cover this distance upstream. So this gives me speed upstream. So I get half kilometers divided by 1/4 hour. This gives me 1/2 times 4 kilometers per hour, which is 2. So I know that speed of that man upstream is 2 kilometers per hour. We know that the speed in still water is 6 kilometers per hour. So speed upstream is 2 kilometers per hour. Speed in still water is 6 kilometers per hour, and we wanted to find the speed of the stream. So we know speed upstream is nothing but difference of the speeds. That is, upstream is difference of speeds. So speed upstream would be speed in still water minus the speed of the stream. So from here you can find the speed of the stream. So speed of the stream would be equal to speed of still water, which is 6 kilometers per hour, minus this comes here, which is speed upstream. Speed upstream is 2 kilometers per hour. So this gives me that speed of the stream is 4 kilometers per hour. So the person swims in the still water at the speed of 6 kilometers per hour. The speed in which he is moving upstream is 2 kilometers per hour, and the speed of the stream is 4 kilometers per hour. So which is this? Which we've just calculated, that speed of stream is 4 kilometers per hour. So remember this special case. In this case, when objects are moving in the opposite direction, that is when the man is moving against the stream or the boat is moving against the stream, what happens is that the relative speed is the difference of speeds. The speed decreases. So when you are moving with the stream, or when you're swimming with the stream, when the boat is moving with the stream, what is happening is that you're moving downstream. So when you move downstream, that is with the stream, the speed increases. That is, the relative speed in that case would be the sum of speeds. So even though they are moving in same direction, the relative speed is the sum of speeds. So remember upstream and downstream. In upstream it is difference of speeds. In downstream it is the sum of speeds.